In this class, we introduce the concept of sequences and series. We define what a sequence is and what a series is and different types of sequence and series. And thereafter do some examples. So let's begin. The sequence is simply a set of numbers which are arranged in order that is governed by a certain rule. Starting definition. A sequence is a set of numbers It can either be finite or infinite. So set is simply a set of numbers arranged in a definite or a defined order according to a certain rule. And this set of numbers can either be finite or infinite. For example, 3, 5, 7, 9, 11 is a sequence. 3, 5, 7, 9, 11. So this is a sequence which is finite, while this one is a sequence which is infinite. So we clearly see that in both of these sequences 1 and 2, the terms are defined by the rule to n minus 1, where n is a term. So 2n plus 1, n is a term. So for example, the fifth term will be given by 2 times 5 plus 1, which is given by 11. So each number in a sequence is what we refer to as a term. Of the sequence. Each number in a sequence is called a term of the sequence. And the terms are usually denoted by T1, T2, T3, Tn. So which simply means first, second, third, nth terms respectively. So therefore, we can have some examples here. Find the next three terms of the sequence. Four, 7, 10, 13, and find a rule that governs the sequence. So it's to find the next three terms of this sequence, 4, 7, 10, 13, and then to find a rule that governs any general or arbitrary term in the sequence. So solution. So here we can actually form a small table, say term position, and then term. So first position, the term is 4. Second position, the term is 7. Third position, the third is 10. Fourth position, the term is 13. Now we see that if we call this one T1, T2, T3, T4, we see that T2, which is 7, is the same as 4 plus 3, which is the same as T1 plus 3. And then T3, whose number is 10, is the same as 7 plus 3, which is T2 plus 3. And then T4, the term is 13. And so 13 is the same as 10 plus 3. And 10 is the third term plus 3. So this means that the consecutive terms actually are differing by a difference of 3. So if you have the first term, the second term will obtain by adding 3. If you have second term to get the third term, you will get it by adding 3. So therefore, T5 will be simply T4 plus 3, which will be 13 plus 3 to get 16. T6 will be T5 plus 3, which will be 16 plus 3 to get 19. T7 will be T6 plus 3, which will be 19 plus 3, which is 22. So therefore, the next three terms, are 16, 19, and 22. Now let's try to get a general pattern for this sequence. So we have found out that the first term is given by 4. So where n is 1. Then second term, T2, is given by 7, where this n is 2, and this 7 is the same as 4 plus 3. And then T3 is the same as 10, which is the same as 7 plus 3, and here n is 3. So to get this number 4, we can write it as 3 times 1 plus 1. And then this 7 can be written as 3 times 2 plus 1. And 10 can be written as 3 times 3 plus 1. And then T4 was given by 13. 13 can be written as 3 times 4 plus 1. So where n is 4. So we see that T1 is 3 times 1 plus 1. T2 is 3 times 2 plus 1. T3, 3 by 3 plus 1. So T1, n is 1. So this is 1. T2, n is 2. So this is 2. T3, n is 3. This is 3. T4, n is 4. This is 4. And you see each value here, we have constant 3 being multiplied by the value of n. Then at each point, we add 1, 1. So therefore, we can predict Tn to be simply 3n plus 1 to be a gentle term. So this is the rule, general rule for any nth term for that particular sequence. So let's define what we call an arithmetic sequence, and then we define geometric sequence. So arithmetic sequence is a sequence in which any two consecutive terms differ by the same number, usually called the common difference. So it's a sequence in which any two consecutive terms differ by the same number, called the common difference. So any sequence in which any two consecutive terms differ by the same number is called an arithmetic sequence. So an arithmetic sequence can be written as A plus D, A plus 2D, A plus 3D, A plus 4D, etc. Where A is called first term and D is called common difference. Then any nth term of an arithmetic sequence is given by Tn equals to A plus n minus 1 times D. So this is a formula that governs any general nth term in an arithmetic sequence. Then note the common difference can either be positive or negative, and is always given by the nth position minus the nth minus 1 position. So this D. So for example, if you want to find common difference in this sequence 3, 8, 13, 18, etc. So this, remember, this is T1, this is T2, this is T3, this is T4. So D will be given by D equals to T2 minus T1, which should be the same as T3 minus T2, which should be the same as T4 minus T3. So this will be 8 minus 3, which should be the same as 13 minus 8, is the same as 18 minus 13. And in each case, we get 5. Then when the common difference is positive, the arithmetic sequence is increasing, and when it's negative, the arithmetic sequence decreases. So examples of a decreasing arithmetic sequence is, say, 12, 10, 8, 6, 4, etc. So see the difference here will be 10 minus 12, which is the same as 8 minus 10, the same as 6 minus 8, the same as 4 minus 6, and in each case we get negative 2. These are decreasing arithmetic sequence. Then let's define what we call geometric sequence. So a sequence in which the ratio of any two consecutive terms is a constant is called a geometric sequence. So this is a sequence in which the ratio of any consecutive terms is a constant This constant is called common ratio. So this ratio this constant term is called the common ratio usually denoted by R. So if the first term of the geometric sequence is A, and the common ratio is R, the sequence is so this is how the sequence looks like. A followed by AR, followed by AR squared, followed by AR power 3, followed by AR power 4, etc. Where this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. And so clearly, the nth term of a geometric sequence is given by Tn equals to A R power n minus 1. So note, a geometric sequence can easily be identified by taking the ratio of any two consecutive terms. Then this ratio must be the same for any pair of consecutive terms. And remember, the R is given by Tn over Tn minus 1 term. So let's give more definition on sequences and series. So let's define what we call an arithmetic progression or an arithmetic sequence, arithmetic series. So the so-called AP, arithmetic progression. So an arithmetic progression is obtained when the terms of an arithmetic sequence are added. So an arithmetic progression the so-called AP is what is obtained when terms of an arithmetic sequence are added. Then an AP is also called an arithmetic series. So this implies that an arithmetic progression is of the form A plus A plus D plus A plus 2D plus A plus 3D plus other several terms. So where A is the first term, D is a common difference. So the only difference between an arithmetic progression and an arithmetic sequence is the separation between consecutive terms. For a sequence, we have commas. For a progression or a series, we have positive sign. So the nth term of an AP is given by Tn equals to A plus n minus 1D, just in the same way as an arithmetic sequence. So examples of such a sequence is 2 plus 4 plus 6 plus 8 plus 10 plus other several terms. Or so these are examples of APs. Or we can have 5 plus 11 plus 17 plus 23. Then geometric progression. So the so-called GP. So this is what is obtained when the terms of a geometric sequence are added. This is what is obtained when terms of a geometric sequence are added. So a geometric progression, a GP, is also called a geometric sequence, a geometric series. And it is of the form A plus AR plus AR squared plus AR cubed plus AR power 4 plus other several terms. So where, as usual, A is the first term, R is common difference. A common ratio, not common difference, common ratio. So the general nth term of a geometric progression is the same as general term of a geometric sequence, which is given by A times R power n minus 1. Tn equals to A Rn minus 1. So that's how we define a geometric progression. So examples of GPs include 3 plus 6 plus 12 plus 24 plus other terms. We have 48 plus 24 plus 12 plus other terms. Next session, we'll be doing examples on arithmetic sequence and a geometric sequence. Thereafter, we'll do examples on arithmetic progression and geometric progression. Thank you.